Imagine the vast expanse of space as a cosmic highway. Galaxies, like celestial vehicles, travel along this highway, each on its own path. They are separated by unimaginable distances, yet their gravity influences one another, creating a cosmic ballet of attraction and repulsion. Occasionally, these galactic travelers find their paths intersecting, resulting in a cosmic fender bender of unimaginable proportions. One such collision is in our future. The Milky Way, our home galaxy, is on a collision course with our nearest galactic neighbor, Andromeda. This isn't a sudden, catastrophic event. It's a slow, graceful dance that will unfold over billions of years. The sheer scale of this event is hard to fathom, but the outcome is a breathtaking spectacle that will reshape our galactic neighborhood. Andromeda, also known as M31, is a spiral galaxy much like our own. It contains over 1 trillion stars and is estimated to be about twice the size of the Milky Way. This cosmic neighbor, located about 2.5 million light-years away, is the most distant object readily visible to the naked eye. On a clear night, far from city lights, you can spot it as a faint, fuzzy patch in the constellation Andromeda. To find Andromeda, locate the constellation Cassiopeia, a distinctive W-shaped group of stars. Near Cassiopeia, you'll find the constellation Andromeda. Look for a faint, elongated smudge of light, like a misplaced piece of the Milky Way. That's Andromeda, a vast island universe filled with its own stars, planets, and maybe even life. Seeing Andromeda with your own eyes is a humbling experience. The light you see left that galaxy 2.5 million years ago, back when our ancestors were taking their first steps towards becoming human. When you look at Andromeda, you are peering back in time, witnessing light that has journeyed across the universe for millions of years to reach your eyes. The dance of galaxies is governed by gravity, the invisible force that shapes the universe. Every star, planet, and bit of dust exerts a gravitational pull on everything else. In the vast emptiness of space, gravity draws galaxies together in clusters and superclusters, creating a cosmic web of interconnected structures. The Milky Way and Andromeda are part of the Local Group, a collection of over 50 galaxies bound together by gravity. Within this group, Andromeda and the Milky Way are the two largest members and are destined to meet. We are currently hurtling towards each other at a speed of about 250,000 miles per hour. This cosmic collision is not a head-on crash, but rather a complex interplay of gravitational forces. As the galaxies approach each other, their gravitational fields will begin to interact, distorting their shapes and drawing out long streams of stars and gas. The galaxies will swing past each other, their gravity slowing them down before they eventually fall back together in a fiery embrace. The discovery that our galaxy is not alone, and that the universe is expanding, was a revolution in astronomy. This groundbreaking revelation came in the early 20th century, thanks to the work of Edwin Hubble. Using the then-new 100-inch Hooker telescope at Mount Wilson Observatory, Hubble observed distant galaxies and noticed something peculiar. He found that the light from these galaxies was stretched, its wavelength shifted towards the red end of the spectrum. This phenomenon, known as redshift, is similar to the Doppler effect we experience with sound waves. Just as the pitch of a siren drops as it moves away from us, the light from a galaxy is shifted towards the red end of the spectrum if it is moving away from us. Hubble's observations showed that most galaxies are redshifted, meaning they are moving away from us. Moreover, he found that the farther away a galaxy is, the faster it is receding. This relationship, known as Hubble's law, provided the first evidence that the universe is expanding, a discovery that fundamentally changed our understanding of the cosmos. Section 5, the Doppler shift, a cosmic speedometer. The Doppler effect, named after Austrian physicist Christian Doppler, is a fundamental concept in physics that applies to both sound and light waves. It describes the change in frequency or wavelength of a wave in relation to an observer who is moving relative to the source of the wave. Imagine an ambulance speeding down the street. As the ambulance approaches, its siren sounds higher pitched because the sound waves are compressed. This compression shortens the wavelength of the sound waves, causing our ears to perceive a higher pitch. As the ambulance moves away, the sound waves are stretched, resulting in a lower pitch. Light waves behave in a similar way. When an object in space, such as a galaxy, is moving towards us, its light waves are compressed, shifting the light towards the blue end of the spectrum. This is known as blue shift. Conversely, when an object is moving away from us, its light waves are stretched, causing redshift. The amount of redshift or blue shift can be used to determine the speed and direction of an object's motion. Section 6. When galaxies collide. The impending collision between the Milky Way and Andromeda is a slow-motion event that will unfold over billions of years. As the galaxies approach each other, their gravitational fields will interact, creating tidal forces that distort their shapes. Long streams of stars and gas will be drawn out, forming spectacular tidal tails that stretch across hundreds of thousands of light years. The galaxies will pass through each other, their stars and gas clouds interacting gravitationally. This interaction will trigger intense bursts of star formation, lighting up the merging galaxies with the brilliance of newborn stars. Supernovae, the explosive deaths of massive stars, will become more frequent, illuminating the cosmic dance with their dazzling light. Despite the immense scale of this cosmic event, the solar system and our planet are unlikely to be directly affected. The distances between stars are so vast that even during a galactic collision, the chances of stars colliding with each other are extremely low. Our solar system will likely be flung into a new region of the merged galaxy, but life on Earth will continue as the cosmic drama unfolds above. The collision between the Milky Way and Andromeda won't be a simple merger. It will be a complex dance of gravity, stars, and gas, lasting billions of years. As the galaxies approach, their spiral arms will become distorted, and long tails of gas and stars will be pulled out into intergalactic space. The initial pass-through will take millions of years. During this time, the galaxies will pull and stretch each other, triggering waves of star formation. The supermassive black holes at the centers of each galaxy will also begin to spiral towards each other, releasing enormous amounts of energy in the process. After the initial pass-through, the galaxies will swing back around, drawn together by their mutual gravity. This back-and-forth dance will continue for billions of years, with each pass-through further disrupting the galaxies and triggering new bursts of star formation. Finally, the galaxies will merge completely, forming a single, massive elliptical galaxy. The merger of the Milky Way and Andromeda will create a new galaxy, a giant elliptical galaxy that astronomers have dubbed Milkomeda. This new galaxy will be vastly different from the two spiral galaxies that preceded it. It will be more spherical in shape, with a smoother distribution of stars and less gas and dust. The supermassive black holes at the hearts of the Milky Way and Andromeda will eventually merge as well. This merger will release a tremendous amount of energy, creating a powerful quasar that will shine brightly for millions of years. The intense radiation from the quasar could potentially affect the evolution of life on planets in the merged galaxy. While the merger of the Milky Way and Andromeda is a dramatic event, it's important to remember that it's a natural part of galaxy evolution. Galaxies grow and evolve over billions of years, often through mergers and collisions. The Milky Way itself has likely undergone several mergers in its long history. The impending collision between the Milky Way and Andromeda provides a unique opportunity to reflect on our place in the cosmos. It reminds us that the universe is a dynamic, ever-changing place, where even the largest structures are in constant motion. It also highlights the immense scales of space and time that govern the evolution of the universe. Our galaxy, with its billions of stars and planets, is but a tiny island in the vast cosmic ocean, and our planet, with all its diversity of life, is just a speck of dust orbiting an ordinary star. Yet despite our insignificance in the grand scheme of things, we humans have been able to comprehend the universe and unravel its mysteries. We have discovered the laws of physics that govern the cosmos, traced the evolution of the universe from the Big Bang to the present day, and even glimpsed the faint afterglow of creation itself. The study of astronomy and cosmology allows us to see beyond our own planet and appreciate the wonders of the universe in all its glory. The collision between the Milky Way and Andromeda is billions of years in the future. By the time it happens, humanity may be long gone, or we may have evolved into beings beyond our current comprehension. Perhaps we will have mastered interstellar travel and colonized other star systems, ensuring the survival of our species long after our planet is no more. Imagine a future where our descendants, having spread across the galaxy, witness the galactic merger firsthand. They might observe the event from distant star systems, marveling at the cosmic dance unfolding before their eyes. Perhaps they will even have the technology to influence the merger, steering stars and planets out of harm's way. The possibilities are endless, limited only by our imagination. The future of humanity in this vast and ever-changing universe is uncertain, but one thing is clear. The cosmic drama will continue to unfold, with or without us. Our responsibility is to cherish the time we have, explore the universe around us, and strive to understand our place in the grand cosmic scheme.